Okay, so welcome, and this is thermodynamics or heat lecture number 1. Now, how am I going to take this? Let us see. I'll first see what all do you know and what all do you don't know, and then I'll start from what all you know, and then probably we'll get on to what all you don't know. Have you studied thermodynamics or heat before? You must have, right? Any idea what is thermodynamics? What is heat? Thermodynamics is the study of thermo is standing for heat, dynamics is something related to flow. Thermodynamics is basically the study of heat or temperature or whatever you call it, or thermo. Do you know what do you mean by that term heat? How do you define heat? That's the first basic thing that you must understand about heat. What
It
is
is a
heat?
form of energy.
Heat is a form of energy. Okay.
It transfers from cold water to hotter water. It transfers from hotter water to colder water.
Okay, heat is a form of energy. That is absolutely correct. Nothing wrong with it. So, if I had to define heat, I will define it in the same way. Heat is a form of energy, or I call it, if I use the correct pen, I call it heat is energy in transit. Now, when I say this, I use a term which you might have heard or you might not have heard. This is an English term, transit. Transit means, you might have heard about this word transit when you are, say for example, going from India to US. You might not get a direct flight because direct flights are normally costly. You probably go to Frankfurt. I've been to Frankfurt or London many times, or you go to Heathrow, or probably you go to Dubai. So you then from Dubai you take a flight via Frankfurt to US. The flights are very cheap. When you are in that path, in that process, you call yourself that you are in transit. Transit visa, you might have heard about transit. Something is moving, something is getting transferred. We call it, it is in transit. Heat is energy in transit. Now, this clearly defines what do you mean by heat. Now, with the way you have given me the definition, that is also correct. But if you just say heat is energy, equation, the definition is not correct. And I'm very peculiar about theoretical aspects of things, that things should be absolutely correct in the real sense. So if you just call heat as energy, well, there are other types of energies as well. There is sound energy, there is magnetic energy, there is electrostatic energy that you have read about, mechanical energy, potential energy, kinetic energy, but heat is different from all those energies. Okay, yes, it's an energy. All energies are different from each other, but they're also similar to each other in many aspects. Heat, for that matter, is different from all those because of this word that I've written, transit. And that is why when you say that heat is energy, you must also add that which flows from hotter body to colder body. You can say this, or you can simply say it is energy in transit. Why this thing is so important that you say that it goes from hotter body to colder body, or it is getting transferred, or it is in transit? Why I have to use this word to define heat? What is the significance of this word? Anyone? What is the significance of this word? Why I have to use this word? I mean, why just I can't simply call heat is energy? Yes, heat is energy. Yes, there's nothing wrong in it. But that is an incomplete definition of heat. I have to always add this. Why I should add this? Anyone? So since you have studied heat, so I'll just go 1 or 2 steps ahead. And that is why. And so that I understand what do you understand about heat. If you don't understand it correctly, then it becomes difficult for me to carry on. So I'll make you understand that. Yes, why this word transit is important? Tell me. Any idea? Why this word transit is important in this definition? Why I've highlighted it?
No ideas.
Okay, the idea is very simple. See, physics is very simple. Physics at our level that we are studying in 11th and 12th for JEE, for advanced, whatever, it's pretty damn simple. We're not
It can
studying quantum
change
physics.
form
Quantum physics
also.
is difficult. Yes.
It can change form.
All energies can change form. Why will I call it transit then? Transit has got nothing to do with changing forms. Transit, as I told you, is an English word. And I gave you an example of transit. When you are flying from here to US and you don't take a direct flight, even if you take a direct flight, you call yourself that you are in transit. You have not reached your destination. Your home is in Delhi and then you're going to US to visit. That's your office, whatever. You
It
are in transit.
requires medium to propagate.
Requires medium to propagate. No, that is not the reason why I call it transit. No. Think. See, just think simple. Physics is very simple. The physics at our level is very simple. We're not studying quantum physics. Quantum physics is complicated. We're still trying to figure it out how to study it. Transit. Just because of the word transit, what does the word transit mean? And that is why heat is different. What does the word transit mean? Transit means in transfer. Transit means that it is flowing. That means heat is only defined when it is flowing, when it is in transit. When it is not flowing, when it is not in transit, it is not heat at all. And that's the simple reason why heat is energy in transit, because it is only defined when it is getting transferred. And that is the reason why I use the word, or we use the word transit here. For example, since you have studied, you would have studied, this is a hotter body. Let me just, since you were very comfortable with a hotter body and a colder body, let us start with a hotter and a colder body. This is a hotter body, reservoir A at temperature TA. This is another body, a colder body, body B, reservoir B at temperature B. I connect it, or even if I keep them, I connect them by some conducting rod. That becomes a question. The similar question came in one of the IITs 2 or 3 times, I think, or maybe very recently. I don't remember the year which question has come when. Anyways, if I say that TA is greater than TB, then what happens? What happens if TA is greater than TB and I connect this and insulate everything and all that? What happens? It will start to.
Heat flows from A to B.
It will flow from A to B. Okay. Okay. Now let us make things interesting. So how do I make things interesting? I say that before flowing, before I start this connection, this gentleman had a heat which was, let us say, 50 calories of heat was contained inside this gentleman, and before transfer, 20 calories of heat was inside this gentleman. After transfer, let us say, when the transfer is going on, the heat content inside this is 40 calories, and the heat content inside this is, let us say, 30 calories. So I'm just saying this: heat, heat, heat content, and heat content. Am I making sense? Does the statement that I've said, does it make sense? That before transfer, the heat in reservoir A was 50 calories, and heat in reservoir B was 20 calories. Does it make sense? Does it make sense? Am I saying correctly? Or I say it in a different way. I say what? I'll say it in green. I say that 10 calories of heat has been transferred from A to B. Which statement is making sense? Which I've said 3 statements. First statement is before transfer and after transfer. Before transfer, the heat in reservoir A was 50 calories. After transfer, it is 40 calories. That is statement number 1. Statement number 2, in reservoir B, before the transfer, 20 calories of heat was there. After transfer, it became 30 calories. That is the second statement. My third statement is, oh, 10 calories of heat has been transferred from reservoir A to reservoir B. Which statement is correct and which statement is wrong? Or all are correct? Tell me.
Sir, third option, sir.
Third option is correct. Yes, the third option is correct. What is wrong with first and second? What is wrong with first and second? If you know that third is correct, first and second one must be wrong. Why are they wrong?
In third one, the 10 calories are processed.
In third one? Tell me, no answers are correct and no answers are wrong. It's just I want to understand what you are thinking. Tell me. Why is that? Why do you say that first and second option are wrong? Why do you say that? Tell me. No idea. But you know that first and second are wrong.
No idea.
Okay, not a problem. Now you are there with me, so you will have an idea. The idea is very simple. Heat is only defined when it is flowing. So when I say 10 calories of heat has flown, I am absolutely correct, because then I'm referring to a transfer of energy from a hotter or a colder to a hotter body. Obviously, I know that from hotter to colder, it will flow on its own. From colder to hotter, it will not flow on its own. I'll have to push it. It's very similar to saying that if something is at the top of the hill, it will always come down the hill on its own because of gravity. Potential energy, it has potential energy. Potential energy will always decrease on its own. It will never increase on its own, because the more energy you have, you are less stable. The lesser the energy, more the stability. Everyone wants to be stable. Same criteria here. Heat flows from hotter to colder, just like potential energy. You'll always go from up to down, not from down to up on your own. So when I talk about this energy, when it is contained inside the body, it is not heat. You don't call it heat. You call it internal energy of the body. So the correct statement is, now can you tell me the correct statement? U stands for internal energy, same as potential energy. When it is contained inside a body, it is the internal energy of the body. I hope you are conversant with the term internal energy. When it is inside the body, it is the internal energy of the body. So before transfer, the internal energy of body A was 50 calories. Now, the problem with calories is specifically used for heat, but I'm just using it here as well. Before transfer, the internal energy in the body A, internal energy in body A was 50 calories. After the transfer, it is 40 calories. Similarly, for body B, before transfer, it was 20 calories, and after transfer, it is 30 calories. That is an absolutely correct statement. The third statement was already correct. 10 calories of heat energy was transferred from A to B. Before transfer, the internal energy in body A was 50 calories, and internal energy in body B was 20 calories. After the transfer, the internal energy becomes 40 calories and 30 calories respectively. Do we understand the difference between the two terms, internal energy and heat? Do we understand this?
Yes, sir.
Yes. Well done. Now, to make this point very clear, I always use symbols and things. So whenever I talk about heat, I have to remember that heat is energy in transit. It is only getting transferred. So when I use a symbol for heat. Normally books will use H for heat. I don't use H only. I use delta H for heat. I hope you are you know the term delta. What does the delta stand for?
Change.
Delta stands for change. Yes. And that is why I use this delta, so that it makes me understand that whenever I talk about heat, I am talking about the process where heat is flowing. So this change tells me in my mind that when I'm talking about a process of heat, it is changing. When I'm talking about absolute values, I will write U. U means internal energy, but delta U will mean change in internal energy. And change is always final value minus initial value. Are you all aware of this?
Yes, sir.
So change in internal energy of body A, so I will write it like this. Change in internal energy of body A will be minus 10 cals. Change in internal energy of body B will be plus 10 cals. Internal energy of body A before transfer was 50 cals. Internal energy after transfer is 40 cals. Change in internal energy delta U, how much it has changed. And I use the same delta. So delta tells me in symbols that we are talking about a change. We are talking about a transfer. Heat is only defined when it is in transit. Do we understand this?
Yes, sir.
Okay, that's about heat. Let us go on to the next definition, and the next definition is temperature. What do you mean by temperature? What do you understand by the word temperature?
Measurement of heat.
Temperature.
Measurement of heat.
Measurement of heat, my dear friend. What's your name, beta?
Giant.
Giant. Measurement of heat. Well done. Okay. So let's measure heat by temperature. Okay. So let's measure heat. Now we know that heat is energy in transit. So I cannot measure this because this is not heat. I cannot measure this because this is not heat. The only thing I can measure is this. So I've said that 10 calories of heat has been transferred from A to B. That means calories is temperature, right? Is that correct? I measured heat. So calories must be temperature, right?
Yes, sir.
Yes. Is calories temperature? Calories tell us the temperature of the body. Temperature was here. Oh, temperature was, let us say, 100 degrees Celsius. 100 degrees Celsius. Here the temperature was, say, let us 50 degrees Celsius. Now this 10 calories, how do I relate it to 100 degrees Celsius? So your definition fails. Yes or no?
Yes, sir.
Think about something else. So temperature has got nothing to do with heat. Temperature has got nothing to do with heat. Heat is energy in transit. Temperature is something else. What is temperature? Again, think. See, sometimes the easiest of things are the most difficult to define. We have been hearing temperature since your grade 1. Temperature is night, temperature is hot, temperature is cold, temperature is this, temperature is that, but you still don't know what is temperature. Facts of life, it happens. Simple things are the most difficult one to define. Yes. What is temperature now? Try again. What is temperature? There are no There is nothing right and nothing wrong. I'm just trying to make you understand that you must understand things correctly. That's it. What do you mean by temperature? Try again. Yes, bacha? I'm not able to hear you.
Define, sir.
Yes?
Sir, we don't know how to define.
Okay. It's very simple. You might have heard it, you don't recollect it. It is the degree of. Now, can you complete it? It is the degree of. Degree of.
Sir, I think it measures a hotness or coldness of a body.
Yes. It measures the hotness or coldness. Now, hotness and coldness has got nothing to do with heat. Heat is energy that gets transferred. Yeah, it is not the hotness or coldness of a body. You must understand this. Hotness or coldness is not defined by heat. Because of hotness and coldness, what happens, the transfer that happens, that is the transfer of heat. So I can't define hotness and coldness by heat. So if I say that this body is very hot, yes, it's a correct statement. This body is very hot. But if I say this body has got so much of heat, that is absolutely wrong. Absolutely rubbish. Does not make any sense. Something having more heat and something having less heat is absolutely rubbish, because heat is not that thing which is contained inside the body. Because when it is contained inside the body, it is not heat at all. Then what is that? It is the internal energy of the body, right? But when we try to define temperature, rather than defining in terms of the measure of the internal energy of the body, well, that might sound a bit complicated. We can just simply say that it is the degree or the measure of hotness or coolness. This is a correct definition of temperature. Do we understand this? It is the degree of hotness or the degree of coldness of a body. Second, now because of this temperature, or because of, should I say, temperature difference, what happens is energy flows. Normally, for heat to flow, it will only flow when there is a difference in temperature. And because of this difference in temperature, whatever energy flows, that energy is known as heat. So that is how heat and temperature are related to each other. Am I clear?
Yes, sir.
So that is how you define heat, and that is how you define temperature. Now, there's one more way in which I can think about temperature. Have you heard about Zeroth Law of Thermodynamics?
Yes, sir.
What is that Zeroth Law of Thermodynamics? Any idea?
Sir, if A and B are thermal equilibrium, then B and C are thermal equilibrium, then A and C will be thermal equilibrium.
That is absolutely correct. If two bodies A and B, they are in thermal equilibrium.
And B and C are thermal equilibrium.
B and C are in thermal equilibrium. Then
B and C are also in thermal equilibrium.
now the question is, what do you mean by thermal equilibrium?
Heat flow is equal to 0.
Okay, heat flow is equal to 0. Why you're making it so complicated? You can just simply say that they have the
Same temperature.
yes, they have the same temperature. So basically, Zeroth law of thermodynamics is sort of defining temperature in some way. The temperature means the bodies are in thermal equilibrium. If two bodies have the same temperature, they are in thermal equilibrium. So I can also think of temperature in that sense. So no heat will flow from one body to the other body if they are in thermal equilibrium. So if I want to understand it, I can also understand it in the form of Zeroth law of thermodynamics. Temperature is the degree of hotness, or temperature is the degree of coldness of a body. Now there are different units in which you can measure temperature. The SI unit is how much?
Kelvin.
The SI unit is Kelvin. Then I have degree Celsius. Then I have degree Fahrenheit. Yes or no? You are aware of this?
Yes, sir.
Okay. Great. Chalo then. Let us proceed further and see. So up till here, so far, I think we are good. What is the next thing? So I'll start with this, and just give me a second. I'll just go on to some definitions which are there in this note, and then we will move ahead. And once I'll just go through these. Yes, I hope you can see this. All of you can see this?
Yes, sir.
Heat, the definition of heat. And oops, what I have done here, I've just disturbed it from its equilibrium. Let me draw this heat. Now see, this is a very good explanation of it, and that is why I'm bringing it on the screen right now. The energy associated with the configuration and random motion of atoms and molecules. A body consists of tremendous amounts of atoms and molecules, and they are in random motion, and they are in orientation. They're arranged in specific ways. From there, because of this random motion and because of this arrangement, they have an energy. That energy is known as internal energy, denoted by the letter U. I hope now it is clear that is not heat. And a part of this internal energy, which is transferred, most important term, transferred from one body to other due to temperature difference, is called heat. I hope that makes it absolutely clear what is heat. It is an energy, so it is a scalar. Dimensions are this. Unit, SI unit is joule. Calorie is the practical unit which most of us use. How much is 1 calorie? You must be knowing this. 1 calorie is defined as the amount of heat energy required to raise the temperature of 1 gram of water to 1 degree Celsius. The change in temperature has to be from 14.5 to 15.5 degrees Celsius. Heat is a form of energy, therefore it can be transferred into other forms. We all understand these points? Yes or no?
Yes, sir.
Okay, I don't. Do you need to write it down, or shall I move ahead?
No, sir. Sir,
Okay.
wait for a few minutes, sir.
Okay. Just note it down. In any case, do you have your mobile phones? I mean, are you allowed mobile phones there?
Yesterday we have, sir, but sir took mobile phones.
Okay. So what I'll do is I'll send you this. I think I have 1 and 2 sheets of notes. So I'll send you those sheets. So that will save a lot of your time. Okay. I think you are running short on time, correct?
Yes, sir.
So I'll send you this one.
Sir, print based on.
Print, how can I send a print? I'm not there. I can only send a soft copy. So do you have any Telegram group of yours?
सर है लेकिन है फोन है सर फोन ले लिया
Phone ले लिया. Okay, I'll see what I can do. See, I can't send a printed copy because the time it reaches, it will be too late. Right?
Soft copy.
I can send a soft copy, but where will you see it? So I'll have to arrange for that. I'll ask someone to take a printout of that soft copy and give that to you in hard copy. So
विशाल सर को भेजो सर.
I'll manage that. Okay. Chalo. So far so good. Shall we move ahead?
Sir, did JEE Mains date announced, sir?
No, but I don't think it has been announced. I did not get the news. Let's see.
But advance is announced, no, sir, on July 3rd.
Right. So mains would be there. Don't worry. Let us go ahead and let us finish our task. Let us finish it fast. Okay. Chalo. What next? Work can be converted into heat and vice versa, and we call this mechanical equivalent of heat. Are you aware of this? And that is how we get the
Yes, sir.
recipe in joules and calories. Don't worry, I will send it to you. I'll send a soft copy and you catch hold of Vishal sir and get the hard copies from him. I'll send this one to you. Okay?
Okay, sir.
Okay? Chalo. Now, normally we'll also be talking about work. Here it is in very simple terms. Work is the transfer of mechanical energy irrespective of temperature difference. So whether or not there is temperature difference, this is also a transfer, or work is done when something is shifted. So work, see, something is shifted. Therefore, whenever I talk about work, I do not write work as W, I always write it as delta W, because as energy, work is only defined when something moves. There must be a movement for work to be done. If there is no movement, there is no work done. So you can also define in terms of transfer. Something has to get transferred for work to be done. But because of temperature, if that transfer is happening, that is heat energy. But work can be done without temperature difference. Work can be done with temperature difference. So when there is temperature difference, then only you can shift. When there is no temperature difference, then also you can shift. Work is that thing. Whereas heat is the transfer of thermal energy because of temperature difference. So heat and work and internal energy, they are related to each other very, 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 very strongly. Yes or no?
Yes, sir.
In fact, I can write it like this: delta H or delta Q. Normally we write heat as delta Q is delta U plus delta W. Sorry. We all are aware of this equation?
Yes, sir.
First law of thermodynamics, FLTD. FLTD. In chemistry, it looks a bit different. In physics, it looks a bit different.
Yes,
Delta
sir.
Q. Delta standing for transfer. Delta W, because it also means transfer. Why delta U? Because internal energy is changing. And that is why three deltas here. Most of the good books will write it in this way. The not so good ones will write anything. If I write it in the derivative form, which will be coming in JEE Advanced, dq will be equal to du plus dw. So I can understand it in this way. If this is a system, oops, why this system is okay. If this is a system can consist of anything. If I give it a small amount of heat dq, if I give this a small amount of heat dq, the small amount of heat dq can be utilized in two ways. It might do some work, it might go up and down. You say, sir, how will it go up and down? It will go. If I give it heat energy, it will, that if I have some boiling water, that vapor will come and push it down. That is because of heat. So it might do some work, and there might be a change in its internal energy, not change in heat, change in its internal energy. So this first law of thermodynamics is basically telling us what? It is nothing but it is simply law of what? Law of what?
Thermodynamics.
Law of conservation of energy. Heat is a form of energy. Work and energy are related to each other. Potential energy, kinetic energy, they are related to work. First law of thermodynamics is nothing but law of conservation of energy. It is just telling you the energy I am giving it to this body is in the form of heat. Some part of it will be converted to work, which is also a form of energy. Some part of it will be gone in changing the internal energy of this body. That is first law of thermodynamics. That is also law of conservation of energy. Do we understand this?
Yes, sir.
Okay. Then we move on to the 7th point. Generally, the temperature of the body, this remember, generally, not always. Generally, the temperature of a body rises when heat is supplied. Oops. Can you think about a case where I give heat to a body and the temperature does not rise? Does that happen? I give heat to a body, temperature does not rise. Are you aware of any such process? Yes or no?
No, sir.
You're not aware of any process where you give heat to a body and the temperature remains constant?
No, sir.
You're not thinking hard enough. Have you heard about isothermal process?
Yes, sir.
What happens in an isothermal process? Think, tell me. What happens in an isothermal process? Does the temperature of the body change? If I give heat to a body in an isothermal process, does the temperature of the body change? Yes or no?
No, sir.
Do I give heat to the body? Yes or no?
Sir?
In an isothermal process, can I give heat to a body? Yes or no?
Yes, sir.
Will the temperature of the body change?
No.
So
Constant.
now do you know a process where the temperature does not change when heat is given? Now, are you aware of the process where you give heat but the temperature does not change?
Yes, sir.
That process is?
Isothermal process.
Okay. So you now know a process where you give heat but the temperature does not change. Can you think of something else where you give heat and temperature does not change? Have you heard about a process known as melting or boiling?
Water at 0 degrees Celsius.
Yes. Water at 0 degrees Celsius. If you cool it further, or ice at 0 degree Celsius, if you heat it further, the temperature does not change. The state of the body changes. So that is the second process in which heat is supplied or heat extracted is not utilized, does not change the temperature of the body. It only changes the state of the body. That is known as what type of heat?
Latent heat.
That is known as the latent heat. That is correct. That is known as the latent heat. And the second process is simply isothermal process. What are the conditions for a process to be isothermal? I want a perfectly isothermal process. First answer this. Is a perfect isothermal
Solid.
process possible?
No.
No. What are the conditions that are required to make a process almost isothermal? See, I'm asking you this question because I know, I guess that you must have read about them. If you would have been in the first year, I would not have been asking you this one. I understand that you must be knowing, you must remember, you must have heard. Uh, did you take any class in the previous 2 years, bacha?
No.
So you were studying on your own?
Yes, sir.
Okay. So you have definitely heard about isothermal process. Now, what happens in an isothermal process? You give heat, but the temperature of the body does not change. Now, apply some common sense. Common sense is physics. Physics is common sense. As simple as that. I want the process to be perfectly isothermal. It's not possible, but I want to make it as close to the isothermal curve as possible. The isothermal curve is also known as isotherm. So I want to make it as close to the isotherm as possible. What should I do? The first and the foremost condition is
System to be closed
the system to be closed.
and walls of the container insulated.
Insulated. No, my dear friend. No, bacha. It is absolutely reverse of it. So if this, I'll talk about systems and closed and open when we come to first law of thermodynamics. Then I'll take
To
a
be
class.
bad conductor of heat.
No, never, never say that. It has to be a bad conductor of heat because that is absolutely the reverse of it. You can't say the reverse for a thing, right? If this isothermal process has to be conducted here in this container, closed container, let us say, can be open as well. If it has to be a closed container, this has to be made up of perfectly conducting body. It should be a perfect conductor of heat so that whatever heat I give it, it conducts. It gives it away.
Chamka, sir.
Chamka? If the temperature of the contents inside, the gas inside, if it wants to rise, it will just conduct it outside. Oh, let it go outside. Let it not change the temperature of the body. Let me help it in dissipating that heat outside. So it must be a perfect conductor. That is the first condition. It must be a perfect conductor. Must be perfect conductor. I know I'm deviating from the issue, but the class is all about that. You know it before. So must be a perfect conductor. What is the second condition? There is second condition also. What would be the second condition? I want the process to be perfectly isothermal. Think, and you will have the answer. Perfectly conducting body is there. How do I proceed? What should be the next condition? The process should take place extremely slowly. Why extremely slowly?
Was a static motion.
Huh? Quasi-static process. Yes, it should be in equilibrium at all points in time. That is first thing. And the second thing is it must be extremely slow. But why I want to be slow? Why I can't make it fast? And the reason is perfectly logical. Why it has to be perfectly slowly, extremely slowly? Because I want. No, basically what I want to, why I have these two conditions. These two conditions are coming from a single cause. And the cause is I want the heat to be transferred. As soon as heat is given, the heat has to be transferred, right? Heat needs to be dissipated or transferred. Heat needs to be dissipated. Or in other words, if I say, now obviously we are going to do this isothermal process, let us say on Earth. In Earth where there is atmosphere. So what I need to do, there must be a continuous exchange of heat between the system and the surroundings. Do we understand this?
Yes, sir.
The system and the surrounding must be continuously changing heat. Not changing heat, transferring heat. We must be in perfect synchronization, perfect resonance. Heat must be continuously transferred. As soon as heat comes, it must be transferred. So if as soon as heat comes, it is getting transferred, my internal energy will not change, my temperature will not change because I am not taking anything inside, I'm just throwing it outside. Dude. Coming, that's going, coming, that going. My temperature will not rise. That is the only way I can keep on taking heat but not raise my temperature. Whatever comes, but whatever comes, but And how do I make it possible? I make it possible if I am perfectly conducting body, so whatever heat is getting generated, I throw it out. And I need time for that heat transfer to take place. I want that heat to be transferred, but it will take time. Nothing can be instantaneous. Even light is not instantaneous, it has a speed. So there must be some time that should be given for me, for my body to transfer that heat. And therefore, I want the process to be done extremely slowly. So an extremely slow process almost does not show any sign of motion. That is an isothermal process. Perfectly conducting body should be done extremely slowly. What is the reverse process of isothermal? Next question. What is the reverse process of an isothermal process? You have heard about it. Reverse it. Reverse
Not
it.
be a
Reverse it.
perfect conductor.
What?
It should not be a perfect conductor.
Not using your head. So the condition in that process must be, here there is a continuous transfer of heat energy. What should be the condition in that process? There should be no transfer of heat. Continuous ka ulta. Continuous. Hey, no transfer of heat. How do I make that process possible? There should not be any transfer of heat between the system and the surroundings. Reverse the other two conditions. What are the other two conditions? What would be condition number 1 now? Array, what is the opposite of conductor?
Bad conductor of heat or insulator.
Insulator. It must be a perfect insulator. I reverse the condition. Then what is the second condition? It must be extremely fast. Do you know the name of this process?
Quasi-static.
How can? Yes, we normally take it as quasi-static. An ideal adiabatic process, reversible process is quasi-static, but there are also irreversible adiabatic processes. And last year there was a question on this irreversible adiabatic process. No, not last year. In some paper I saw it. Extremely fast, happening inside a perfect insulator. What is that process known as? No heat transfer takes place in that process. What is that process? You know that process. You have done problems on that process. That process is
Adiabatic.
adiabatic process. Yes, that process is adiabatic process.
1 minute.
Adiabatic and isothermal are the opposite of each other. I don't know whether you have heard it or not, but it is so. Seen it, shown it. Okay, so I wind up today's class here because I have another class, and we'll continue on this. I will send you the sheet so that in the class you have sheet in front of you that will make the process extremely fast, because we cannot be isothermal, we cannot be extremely slow in our progress. We have to be extremely fast, but again we have to be extremely conducting, so that no, we must be perfect insulator here. Well, whatever I say to you, that must get inside your body, and you should not conduct it outside. Keep it inside, and if you want to conduct it outside. So the process that we are looking at in this class is a perfectly adiabatic process. It must be extremely fast, and it must be, your body must be a perfect insulator, so whatever remains inside your body. Okay, chalo then, we'll meet in the next class. Next class is tomorrow, and we'll go ahead. I'll send you this. If you have any problems, you can obviously ask me at any point in time. Okay, chalo, take care. I hope you enjoyed this class. Take care. Enjoy.